Let's talk about Le Chatelier's principle and how that affects chemical equilibrium. Le Chatelier's principle states that if a chemical system is at equilibrium and it is disturbed or stressed, then the system will react in a direction that counteracts the disturbance, or it will react in a direction that relieves that stress. The factors that affect the equilibrium, or the stress that can affect the equilibrium, are concentration, temperature, and pressure. A couple things I want you to pay attention to are some of the symbols that we're going to be using. For concentration of any molecule, we will be using brackets. So this means the concentration of A, or any molecule we're talking about. When we're talking about pressure, think of it in terms of energy. And when we're talking about pressure, think of it in terms of gas moles. All right, let's talk about the first example. We are going to stress some of the concentrations of the different parts of this reaction. So just remember that the equilibrium will shift in the opposite direction of the stress. So I'm going to always examine my chemical equation or my chemical equilibrium in terms of where I'm adding stress. So here's our first reaction. Carbon monoxide reacts with oxygen to yield carbon dioxide. It's asking what happens if the concentration of carbon monoxide is increased. So in terms of stress, that means I'm adding stress to the left. So that means the reaction wants to counteract that stress and go towards the right. So if I'm adding stress on the left, that means I'm going to be increasing the concentration of CO2, and I'm going to be decreasing the concentration of O2. If the reaction is going towards the right, it's going to be making more of the products and less of the reactants. Okay, let's talk about what happens if the concentration of CO2 is increased. So that means I'm adding stress to the right side. If I'm increasing my stress on the right side, that means the reaction is going to go towards the left. If it goes towards the left, then I'm making more of the reactants. So that means I'm going to increase the concentration of CO, and I'm going to increase the concentration of oxygen. And what happens if the concentration of CO is decreased? Now, we've explained Le Chatelier's principle in terms of adding stress. The wording of this question can mess you up a little bit. It says, what happens if CO is decreased? Here's CO, it's on the left, but I want to decrease it, so that just means I'm adding stress on the right. And if I add stress on the right, that means I'm going to shift my equilibrium to the left. So that just means that I'm going to increase the concentration of oxygen. Let's take a look at another example. I have a new chemical equilibrium, and I want to remember that the equilibrium will shift in the opposite direction of the stress. It's asking what happens if H2O is removed. And Le Chatelier's principle is explained in terms of adding stress. So if I remove H2O, that just means I'm adding stress on the left side. So let's repeat that. If I'm removing H2O, then my stress is really on the left side. If I'm adding stress on the left side, then the reaction will go towards the right. If the reaction is going to go towards the right, that means I'm increasing the concentration of C2H4, And I could be also decreasing the concentration of C2H6O. Okay, let's talk about the second factor, temperature. The equilibrium will shift in the opposite direction of stress. So I have a reaction. I also have the delta H of this reaction. Because it is a positive delta H, then I'm going to remind myself that this is an endothermic reaction. And endothermic reactions means that there is energy on the reactants. Okay, now I can take a look at the factors and try to examine what happens. It's asking what happens if temperature is increased. If temperature is on my left, that means the reaction will go towards the right. If that happens, then, let me go ahead and write that down. If that happens, then that means I'm going to increase the concentration of NO, and I might go ahead and explain the other concentrations. I can say concentration of N2 decreases. I can say O2 decreases. I can also say that the reaction will go towards the right. All of these are going to be acceptable answers if you're doing a multiple choice question test. It's asking in the second question, what happens if temperature is decreased? Because this is an endothermic reaction, that means energy has to be on the reactant side. So that just means that I still have to consider energy on the left side, but if it's being decreased, that means I'm adding stress to the right side. And if I'm adding stress to the right side, then the reaction will flow towards the left. So if the reaction is flowing towards the left, then I can say that the concentration of N2 increases. I can say the concentration of oxygen increases. I can say that the reaction will shift to the left. All of those are acceptable answers depending on the specific question or the multiple choice portion of it. Let's take a look at another example. I still want to remember that the equilibrium will shift in the opposite direction of the stress. I have a new chemical equilibrium. I also have a delta H. The delta H is negative. So this just reminds me that this is exothermic. And if it's exothermic, that means my energy has to be on the product side. Exothermic means energy is on the product side. It's asking what happens if temperature is increased. My temperature is my E, so that means I'm going to add the stress to the product side. The reaction will flow to the left. So that means that I can say that the concentration of N2 increases. I can say the concentration of H2 increases. I can also say that the reaction shifts to the left. All right, let's talk about what happens if the temperature is decreased. Energy is still on the right, so that means I'm increasing my stress on the reactant side. If I'm increasing my stress on the reactant side, that means the reaction flows to the right. That just means I'm increasing the concentration of NH3, and I might even say the reaction favors the right side. All of those would be acceptable answers. Let's talk about changes in pressure. Now, when we're talking about pressure, we're actually examining the gas moles. So when pressure is increased, that means the equilibrium will shift towards the fewer gas moles. And when pressure is decreased, the equilibrium will shift towards the more gas moles. So we're going to have to take into consideration our gas moles. Here I have a chemical equilibrium, and if you notice that these are all gas molecules that we're dealing with. So now I have to, before I even answer the questions, I'm going to count my gas moles. On the left side, my reactants, I have 4 gas moles. And on the product side, I have 2 gas moles. Okay, let's try to answer these questions now. What happens if pressure is increased? If pressure is increased, the equilibrium will shift towards the fewer gas moles. So that just means that the reaction will shift to the right. If the reaction is shifting to the right, then that means I'm making more of the NH3. What happens if pressure is decreased? If pressure is decreased, then the equilibrium will shift towards the more gas moles. So that means the reaction will shift to the left, and that means I'm making more N2 and more H2. Good luck and keep practicing.